All right, 3.5, operations on functions. Good thing I knew where this was. Sums and differences of functions. If f and g are functions, their sum is the function h, which is defined by the rule f of x plus g of x equals h of x. Or if you say it the way it's written, h of x equals f of x plus g of x. So, for our example, we have f of x equals 3x squared plus 2, and g of x equals 4x minus 2. What's happening? Okay, so then f of x plus g of x is equal to just adding these two together. 3x squared plus 2 plus 4x minus 2. Combine those two. The 3x squared stays by itself because we can only combine like terms. Plus 4x, and then 2 minus 2 is 0, so we're done. Easy peasy. Like and subscribe. This is an easier section, especially here at the beginning. All right. Oh. For F. So it works the way with subtraction as well, because that's what we wrote in the beginning for sums and differences. Sum means add, minus means subtract, like and subscribe means that you like and subscribe. So write the rule for f plus g. F of x is the square root of 9 minus x squared, and g of x is the square root of x minus 2. Let's go. So write the rule for f plus g. Now, whenever I add a square root and a square root, I can't combine them unless it's, well, I just can't combine them at all, ever. So it would be different if it was like square root of 64 and square root of 49, because then I could do 8 plus 7, but it's not like I can add 64 plus 49 and get 15. It just doesn't work like that. So, if I was looking to find f plus g, it would be the square root of 9 minus x squared plus the square root of x minus 2. And that's it. Can't do anything else with it. That's the answer. So, what about f minus g? Do you think I would be able to subtract those? Unless they were the same number. Yeah. If I got it to be the same number, I would be able to subtract them, but I don't know, so it stays as this. Yeah, but with a minus sign in between. So it can't be again. Because Woosah. This is going to be one of my all-time greatest videos. Oh, but now we get to the hard part. Find the domain for each. So if I'm trying to find the domain of f plus g and the domain of f minus g, first I need to find the domain of each one of these. So if you'll remember correctly, the domain is the numbers where it's possible. So let's find the domain for each piece of this. What is the domain of the first one? anytime I take the square root can't be less than 0, right? So I need to plug in numbers that would make this greater than or equal to 0. So what's the highest number I could plug in for x? Well, let's say I plug in 4. 9 minus 4 squared. What's 4 squared? 16. So then I would have 9 minus 16, which would give me the square root of a negative 7. Can I take the square root of a negative? No. I can only take the square root of a 0 or higher. So it can't be going up to infinity. It can't be all real numbers. There has to be some cutoff here. So if I'm looking to solve that, the easiest way to do it is to do 9 minus x squared equals 0. Or make it greater than or equal to 0. So now, if I'm looking for this, I would subtract the 9 over. That gives me negative x squared is greater than or equal to 9. Negative 9, because I subtracted the 9 over. Divide by a negative 1, that gives me x squared is greater than or equal to 9. Take the square root of both sides. That gives me x squared. I'm sorry, I took the square root. That gets rid of the squared. So that gives me x is greater than or equal to 3. Do you remember what happens when you take the square root of a variable squared? It makes it so we have to add in the plus or minus. I did something wrong here too, by the way. Right here, whenever I divide it by the negative, I have to flip my inequality going the opposite direction. So that should be less than or equal to 9. That's better. So then taking the square root of both sides, it gives me a plus or minus solution. So I would get x has to be between 3 and negative 3. Because if I plug a negative 3 in for x, negative 3 squared is positive 9. So I have to take that solution into account. So that's my domain for the first function. Now I need to find my domain for the second function. In other words, x minus 2 has to be greater than or equal to 0. Add the 2 over. That gives me that x has to be greater than or equal to 2. So, when I take this portion of my domain, in conjunction with this portion of my domain, it leaves a very limited range of numbers that it could be. This says it has to be any number between negative 3 and 3. So if we look at like a number line here, dealing with the f function says it has to be between negative 3 and 3. But dealing with the g function, it says it has to be between 2 and 3, or greater than or equal to 2. So I have to take the area that's covered by both. So that would mean that for my domain, it's x is between 2 and 3. Because if I put in any other number outside of between 2 and 3, it's going to give me a non-real answer. All right, well, that is it for the day. If you have any questions, don't hesitate to ask them. Otherwise, have a good day, and I'll post the homework for tonight.